Well, hello and welcome to this. Sorry, welcome to this exercise on quadratic patterns, which involves spatial awareness. A GCSE, IGCSE type question, and it says the three figures represent three towers constructed with cubes. Some of the cubes are hidden. They say figure one has only one cube, and figure two has 6 cubes. Like you see for figure 2, we can see 5 cubes, but one of them is hidden underneath the cube at the top. So we've got 6 cubes in figure 2. It then says, write down the number of cubes in figure 3. Now, don't forget that each of these structures is symmetrical. When you've got a plane of symmetry. So you double things on one side. Count one side and double. Okay, so we've got 1 there. That's 1 cube. 2 and 3. Now if we double that, we get 6. That's 7. And that's 8. Now if we add 6 from figure 2, as it were, add the 6 here, that gives us 14. Now this 6 on top of the bottom layer hide 5 more cubes beneath. So if we add 14 to 5, we have 19. So we've got 19 cubes for figure 3. And then it says, draw a plan view of the arrangement of cubes for the bottom layer of figure 4. So we need to find the number of cubes in the bottom layer of figure 3. Now we know that figure 3 has got 19 cubes. Now 6 of those cubes are from figure 2. So 19 minus 6 will give us 13. So there are 13 cubes at the bottom layer of figure 3. Now for figure 4 bottom layer, we need to cover all the exposed faces of the bottom layer of figure 3. So we need 1 cube to cover this face here. That's 1. That's 2. That's 3. That's 4. That's 5. And that's 6. Now double 6, you get 12. Now add 12 to 13, we have 25. So there are 25 cubes at the bottom layer of figure 4. That's what you got there. 1 for figure 1, 5 for figure 2, 13 for figure 3, and 25 for figure 4. Okay, now we need to draw a plan view of the arrangement of cubes for the bottom layer of figure 4. Right, now this is figure 4. Now can you check and make sure that this is right? Okay, this is figure 4. If you count this properly, you see that we've got 25 cubes in the bottom layer of figure 4. Now, just to help us out here, to draw the plan view, there's this one here on its own. Now for this row, second row, there'll be 3. 1, 2, and 3. Yes? Okay. Now for the next one, there should be 5. 1, 2, 3, down 4, and then 5. So you're going to have 1, 3, 5, 7, 5, 3, 1. Okay, because it's symmetrical. You go to 1, 3, 5, 7, and then 5, 3, 1. So the plan view for the bottom layer of figure 4 is going to be something like this one here. Right? So as you can see, we've got 1, 3, 5, 7, 5, 3, and then 1. Now, can you check that that makes sense? So that's part B done. Now for part C. Okay, now for the last part, which says find an expression for the number of cubes, the number of cubes used in the bottom layer of figure N. Now, if we bring down the table from part B, we have this here. So we've got N, we don't know what the number of cubes in the bottom layer of cube N is, or figure N is. So, and a question mark there. Okay, now if you look at 1, 5, 13, 25, look at the incremental figures from 1 to 5, there's an increase of 4. From 5 to 13, there is an increase of 8. And from 13 to 25, there is an increase of 12. So clearly, whatever formula we have cannot be linear. Okay, so the first line of difference, the numbers are not consistent, but for 8 and 12. So we try the difference between 4 and 8, and that gives us 4. The difference between 8 and 12, again, that gives us 4. So the second line of difference is constant, is at 4. So which seems to me that we suggest that the pattern 1, 5, 13, and 12 and 25 will give us a quadratic expression. So for a quadratic expression, we expect something like an squared plus bn plus c. Now, in this case, by convention, a is half of the figures in the second line of difference there. So if we have 4, we get 2. So a is 2. So we don't have that 2. We have 2n squared to start with. So we need to find what's left. So now what's left for each figure, the number of cubes minus 2n squared will be what's left. So for instance, for figure 1, we have 1 minus 2 times 1 squared. 2 times 1 squared is minus 2. So 1 minus 2 will give us minus 1. For figure 2, we have 5 cubes. 5 minus 2 times 2 squared will be 5 minus 4 times 2 is 8, and 5 minus 8 will give us minus 3. Similarly, for figure 3, where we've got 13 cubes, we already know 2n squared. So 2 times 3 squared. 3 squared is 9. 9 times 2 is 18. So 13 minus 18 will give us minus 5. And similarly, for figure 4, we got minus 7. So we got this pattern here of minus 1, minus 3, minus 5, and minus 7. And they decrease by 2, or if you like, minus 2. So the formula or the expression for minus 1, minus 3, minus 5, minus 7 is going to be minus 2n plus 1. Okay? For instance, for figure 1, where n is 1, minus 2 times 1 will give us minus 2, minus 2 plus 1 will give us minus 1. And for figure 2, where n is, for figure 2, where we got minus 3, now minus 2 times 2 will give us minus 4, minus 4 plus 1 will give us minus 3. So for this pattern of minus 1, minus 3, minus 5, minus 7 is minus 2n plus 1. And if we include 2n squared, we then have that the expression for the pattern 1, 5, 13, 25 will be 2n squared minus 2n plus 1. Okay. Now, method 2, for method 2, Again, bringing down an squared plus bn plus c, that's what you expect. Now, usually 2a is equal to the number at the second line of difference. So 2a is equal to 4, which case a is equal to 2. Right. So we then have that 2n squared plus bn plus c is equal to the number of cubes at each bottom layer. Right. So if n is 1 for, say, for the figure 1, if n is 1, we then have 2 times 1 all squared plus b times 1 plus c. And we got 1. So the number of cubes in the bottom layer of figure 1 is 1. And if we then subtract 2 from both sides, we have that b plus c is equal to minus 1. Similarly, for figure 2, where n is 2, we have 2 times 2 squared plus b times 2 plus c. That's 5. If we then, because 2 squared is 4, 4 times 2 is 8, if we then subtract 8 from both sides, we end up with 2b plus c is equal to minus 3. But 5 minus 8 is minus 3. Right. If we then if we then subtract 1 if we then subtract equation 1 from equation 2, we then have that b is equal to minus 2 because the c's will cancel out. So b is equal to minus 2. Now, substitute b is equal to minus 2 into equation 1. We end up with c be equal to 1. So we now have that b is minus 2, c is equal to 1. So our final expression for figure n is going to be 2n squared minus 2n plus 1. Now, I do hope all that made some sense, and please subscribe. Thank you for watching. Bye-bye now.